Prior to the 1920s, chemists doubted the existence of molecules with molecular masses greater than a few thousand. Hermann Staudinger, a German chemist who studied natural compounds like cellulose and rubber, challenged this idea. He proposed that they were composed of macromolecules made up of 10,000 or more molecules. His contributions led him to win the 1953 Nobel Prize. Polymers are molecules composed of long chains of repeating units known as monomers. The Greek root poly, meaning many, and the Greek root mer, meaning part or segment. These monomers, which polymers are made up of, are macromolecules, and a polymeric chain can consist of many thousands of these monomers. This is the monomer ethene, which makes up polyethene, the polymer, and many thousands of ethenes can make up polyethene.
Polymerization is the chemical reaction that forms polymers. There are two types of polymerization reactions: addition polymerization and condensation polymerization. Addition polymerization, sometimes called chain growth polymerization, is when the monomer molecules with double bonds bond to each other without the loss of any other atoms. There are three steps to addition polymerization, the first one being chain initiation. The reaction is started through the addition of a free radical. The free radical acts to open the CC double bond by joining to one side of the monomer. This permits the monomers to react with other open monomers on their side. The second step being chain propagation. This process is the successive addition of monomer units to the chains. This process is utilized to lower the overall energy of the system. The final step being termination. This process can occur through the addition of a terminating free radical or when two chains combine. This is the final step to addition polymerization. Another type of polymerization reaction, as stated before, is condensation polymerization. This is a form of polymerization in which monomers react with each other to form larger structural units while releasing smaller molecules such as water or methanol. An example of a condensation polymerization reaction is esterification of carboxylic acids with alcohols. This can be illustrated here, where a carboxylic acid reacts with an alcohol to form a polyester and water.
There are many ways to classify polymers. The first way, or one way, is based off their structure. And so, in this way, you can see that there are linear polymers, branched polymers, cross-linked polymers, and network polymers. Linear polymers are composed of long, straight chains of monomers. Branched polymers have are linear polymers, but have branches coming off the sides throughout. Cross-linked polymers are composed of bifunctional and trifunctional polymers. So there's chains of polymers running throughout, and branches connect these chains. And then network polymers are the most complicated type of polymers because they're heavily linked to form networks of three-dimensional linkages. Going down the list of these classifications this way, intermolecular forces increase, and so does the durability of these molecules. There are other ways of classifying polymers based off their structure. There are homomers and copolymers. Homomers only have one type of monomer that repeats throughout the whole chain, and copolymers have many different types, most commonly two types of monomers that repeat throughout the whole chain. And then there's also organic polymers and inorganic polymers, and this is simply differentiated by if there's a hydrocarbon backbone to these chains, and in this polymer there is, and the inorganic there obviously isn't. The last way polymers can be classified is based on solely on their intermolecular forces. There's elastomers, fibers, thermoplastic polymers, and thermosetting polymers. Elastomers have the weakest intermolecular forces and therefore have the greatest elasticity, and thermosetting polymers have the greatest intermolecular forces and are therefore very hard and have the least elastic properties.
There are two different types of polymers: natural polymers and synthetic polymers. Synthetic polymers are derived from petroleum oil and are created by scientists and engineers commercially. Natural polymers, on the other hand, occur naturally in nature and are produced from biological processes. Some examples of synthetic and natural polymers are nylon 6 and polyvinyl chloride, which are types of synthetic polymers, and examples of natural polymers are simple starches and cellulose. They all differ in their chemical properties due to the way they are bonded differently. Also, vulcanization, which is a type of synthetic polymerization, involves rubber, and more specifically, it's the toughing of rubber by cross-linking the polymer strands with sulfur. This just makes the rubber stronger.
Now we're gonna make a synthetic polymer bouncy ball. So what we're gonna need is glue, cornstarch, and borax, and I have gloves and a mask on to prevent ingestion or inhalation of the borax. And so the recipe calls for 3 spoonfuls of glue, 3 level spoonfuls of glue. And that's the glue. 1 level spoonful of cornstarch. That's about right. And 1 level spoonful of borax. And we have to let these interact for 10 to 15 seconds before stirring, which I'm going to do now. Okay, now we're gonna mix it up until we're gonna stir until it becomes very difficult to stir. And as you're seeing, it's becoming a very big clump as these monomers are polymerizing and creating a ball. And so now we have a ball, and at first it's going to be a little messy and sticky, but as you knead it, it'll look like this.
Alright, so like Nico, I will be making a synthetic polymer ball, except with slightly different ingredients. So instead of cornstarch, I'll be using 5 milliliters of water. So first, I'm going to take 3 level spoonfuls of glue and mix it in the bowl, just as Nico did. So just give me a minute. So here goes number 1. Here goes number 2. And for the final one, I'm going to do a little extra because of some displacement. And there's number 3. Alright, so after this, I'm going to need to put in my borax. That's a perfectly level spoonful. And then I have 5 milliliters of distilled water right here. And so now I'm gonna let it sit for 10 to 15 minutes, so we'll just wait here.
Seconds.
10 to 15 seconds. Alright, so now I'm gonna stir it. Oh yeah. This is, here. So this is a little more gooey than the other one.
Yeah.
Wow. So I'm gonna stir till it cannot be stirred anymore. It's getting there. Alright, so now since like nothing's really like coming together anymore, I'm gonna form this into like kind of a ball. Oh. Alright. And here's the ball that I made.
Oh, okay. So in conclusion, both of these reactions worked because of the borax acting as a cross-linker to the glue, and it created cross-linking polymers which allowed them to be very elastic and bouncy, as you can see. And so basically, Andrew's, which is the blue one, we dyed it so we can differentiate them, is a little bit more bouncier because the cornstarch in mine helped bind the molecules together more, and mine is less bouncy and less elastic as well. And yeah, and so synthetic polymers have many appliances in the real world, And was just a fun way to demonstrate how the different bonds can offer different properties.